Almost 7 miles down, the water pressure is strong enough to crush a steel drum flat in less than a second. No light has ever reached that depth on its own. In 1978, the U.S. Navy lowered an unmanned test capsule into the Mariana Trench to see if a new kind of hull could survive that kind of crushing force. The cable that connected it to the surface was the only way anyone would ever know if something went wrong. Partway through the dive, that connection went quiet. Nobody has ever explained what happened to it, and nobody ever will, because the capsule was never found. In the summer of 1978, engineers working under the Navy's DEEP Submergent Systems project prepared a small unmanned test hull for a single, simple mission. It had no crew, no cameras, and no way to move on its own. Its only job was to hang from a steel cable, sink slowly into the Mariana Trench, and record pressure readings from a depth almost no object built by humans had ever reached. The team nicknamed it the Capsule, since it looked less like a ship and more like a sealed metal can built to survive being squeezed by an ocean instead of exploded from within. Engineers had reinforced the hull with a new welding method they hoped could handle pressure beyond 16,000 pounds per square inch, more than 1,000 times what a person feels standing at sea level. If the design worked, it would let the Navy build lighter, cheaper vehicles for future deep dives. If it failed, there would likely be nothing left to study at all. The ship towing the capsule lowered it slowly through the water, setting pressure readings back up the cable every few minutes as it sank. For the first several hours, everything worked exactly as planned. Then, a little past 4 miles down, the readings stopped arriving. At first, the crew assumed a simple signal glitch, the kind of small technical hiccup that happened often on long, slow dives like this one. They tried resetting the connection twice. Nothing came back. The cable itself still felt taut when they checked the tension at the surface, which meant something heavy was still hanging on the other end. But no readings, no signals, and no confirmation that the capsule was even still sealed ever returned. The crew spent the next 2 days slowly winching the cable back up, hoping to find the capsule still attached and simply broken. When the cable finally broke the surface, the end of it was frayed and empty. Whatever had been hanging on the other end was gone. There was no debris field, no oil slick, and no wreckage ever recovered from that stretch of the trench. To this day, nobody knows whether the hull imploded from pressure, whether the cable simply snapped under strain, or whether something else entirely happened almost 4 miles down in total darkness. The Navy quietly closed the project not long after, and for a long stretch of years afterward, almost nobody tried sending anything back into that same part of the trench. Internal reports from the period, later made public through routine declassification, show engineers debating 3 separate theories. One group believed the hull simply failed under pressure exactly as feared. Another believed the cable itself had frayed slowly. Over the 2 days it spent hanging in cold water, finally snapping under its own weight rather than any pressure inside the capsule. A third, smaller group wondered whether a sudden underwater landslide along the trench wall could have snagged the cable and torn it free. None of those theories could ever be tested, since nothing was ever recovered to examine. The project files were eventually closed with a single line summarizing the outcome, stating only that the cause of loss remained undetermined. Building a vehicle that could survive that kind of pressure took enormous amounts of money and time, with no guarantee that the effort would pay off. It would take a very different kind of machine, one built to move and film on its own, to finally go back down and figure out what was actually living at those depths. By the early 1990s, a small team of ocean engineers had built a free-swimming robotic vehicle known simply as Pathfinder, designed to explore the deepest parts of the ocean without a single cable connecting it to any ship above. Instead of hanging from a line like the capsule had, Pathfinder carried its own battery power, its own thrusters, and a set of pressure-hardened cameras built to survive the crushing environment of the deep trench. On its very first attempt to reach the bottom of a deep trench near the Mariana chain, something went wrong almost immediately. About 3 miles into the descent, one of Pathfinder's ballast tanks failed to seal correctly, and the vehicle began tumbling, instead of sinking in a controlled straight line. The team above lost their tracking signal for almost 40 minutes, watching a blank screen and wondering whether they had just lost their entire vehicle on its first real test. When Pathfinder eventually reappeared on sonar, rising instead of sinking, the crew realized the tumbling had accidentally triggered its emergency buoyancy system early. The vehicle surfaced days ahead of schedule, dented and scraped but completely intact. Engineers studied the failed seal for months afterward and eventually traced the problem to a tiny manufacturing flaw in a single rubber gasket. It was a clear physical explanation, the kind the capsule never got. Pathfinder went on to complete dozens of successful missions over the following years, mapping trench walls and collecting sediment samples that helped scientists understand how little life needed to survive that far down. Each mission added a little more detail to the map, filling in stretches of seafloor that had never been photographed before. Engineers on the team later said that near failure on the very first dive changed how they designed every vehicle afterward, since it proved that even a tiny manufacturing flaw could turn a routine test into a near disaster almost instantly. In the years that followed, a newer generation of tethered vehicles took over the deepest missions, built specifically to stream live video back to a ship instead of only recording it for later. One of these vehicles, developed by a marine research institute on the West Coast and known by the simple nickname Horizon, became the first machine to send back real-time footage from the floor of the Mariana Trench during an extended dive in the early 2010s. Horizon spent close to 9 hours resting on the seafloor, letting a team of scientists watch a live picture of the trench bottom unfold on a screen instead of waiting for a vehicle to resurface with recorded tape. It captured slow-moving worms, strange transparent shrimp, and long stretches of featureless gray mud that stretched farther than any camera light could reach. Horizon's success convinced its research team to plan a second, longer expedition for the following year, aimed at exploring a section of trench even deeper than anything it had reached before. That second trip never happened. A few months before the planned return, while Horizon was working in a completely different deep trench thousands of miles away, its live feed cut out without warning during a routine ascent. The recovery team searched the surface for hours before spotting floating wreckage scattered across the waves. Once examined, the wreckage told a clear story. A section of Horizon's outer housing had cracked under pressure and imploded almost instantly, most likely triggered by a tiny defect that had gone unnoticed during inspection. It was a painful loss for the team that built it, but at least it was an explainable one, backed by physical evidence anyone could examine. The lead engineer on the project later said losing Horizon felt different from an ordinary equipment failure, since the vehicle had spent 9 hours letting an entire team watch the bottom of the ocean together in real time, only to disappear months later without anyone able to see it happen. If you are enjoying this kind of deep-sea history, sticking around and subscribing helps this channel keep digging up stories like it. With Horizon gone, the research team preparing for their next Mariana Trench expedition had to completely rethink their approach. Instead of a single tethered vehicle, they built a set of untethered landers, boxy metal frames roughly the size of a washing machine, packed with cameras, bait, and sensors, designed to sync freely with no cable attached at all. 4 separate landers went down together on the same expedition, each one built for a slightly different task. 2 carried baited cameras meant to lure in scavengers close enough to film clearly. A third carried a small mechanical claw built to collect samples of mud and rock from the seafloor. The 4th carried extra battery power and a hydrophone meant to record any unusual sounds during the long descent. Because none of the landers had a cable, there was no live video feed, and no way to know what was happening to them until they either floated back to the surface on their own or failed to return. That gap between sending something down and finding out what happened to it is exactly what turned this expedition into a tense, uncertain waiting game. All 4 landers sank together into the same stretch of trench, each one carrying thick glass spheres filled with air to help it float back up later. Partway through the mission, the hydrophone on one lander picked up a sudden, sharp burst of sound, similar to a small explosion, then silence. When the team tracked the location afterward, they found a scattered debris field on the surface where that lander should have surfaced whole. A glass flotation sphere had almost certainly cracked and imploded under the extreme pressure, destroying the lander around it in a fraction of a second. The other 3 landers, sent down at the same time, resurfaced exactly as though planned, fully intact and loaded with hours of footage. For the team, standing on deck, listening to that recording afterward, the sound itself was almost worse than silence would have been, since it confirmed instantly that something had gone catastrophically wrong rather than leaving room to hope for a simple communication glitch. What those surviving cameras recorded made the entire risky expedition worth it. The baited traps had drawn in swarms of small, shrimp-like scavengers that stripped every scrap of bait down to nothing within hours, exactly the kind of behavior researchers expected from deep trench life. But one camera also caught something far rarer, swimming slowly past its lens. A long, pale, almost translucent creature with a wide, flattened head and thin, trailing fins, moving through water so cold and dark that almost nothing was expected to survive there at all. Marine biologists who studied the footage afterward believed it likely represented a species never formally documented before, though confirming that would require capturing and examining a physical specimen rather than video alone. Scientists already understood part of how creatures like this survive crushing pressure that would instantly kill a human. Certain natural compounds build up inside their cells, helping proteins stay stable instead of collapsing under the surrounding water. Pressure. Researchers studying trench life have noticed that animals living deeper tend to carry higher concentrations of these compounds, almost as if the ocean enforces its own natural limit on how deep any living thing can survive. That explains part of the picture, but not all of it, and scientists are still trying to understand exactly how life manages to thrive in a place with almost no light, freezing temperatures, and pressure beyond anything found anywhere else on the planet. Researchers hope future missions using similar landers might eventually capture a live specimen of the creature caught on camera that day, since a physical sample would let them study its biology directly instead of relying on a single blurry pass in front of a lens. None of these losses happen because of a hidden creature or a deliberate cover-up. Every explanation that scientists eventually pieced together came from recovered debris, hydrophone recordings, or careful engineering review after the fact. Pathfinder's tumble got explained by a single faulty gasket. Horizon's implosion got traced to a hidden defect in its housing. The shattered lander's final moments were captured clearly on a hydrophone recording. But the very first loss, the one that started this entire pattern back in 1978, never got that same kind of resolution. No wreckage ever surfaced, no debris field ever appeared, no explanation was ever confirmed for why an unmanned Navy test capsule stopped sending signals nearly 4 miles down and simply never reported back. Every vehicle that followed it into the Mariana Trench eventually told scientists exactly what had gone wrong. Even when the news was bad, the capsule never got the chance. It is still down there, somewhere, or what is left of it is sitting in total darkness at a depth almost nobody has ever reached, holding onto an answer that has stayed missing for nearly 50 years. Every few years, a new research team proposes searching that same stretch of trench with updated sonar equipment, hoping modern technology might finally spot wreckage that older instruments simply could not detect. So far, none of those proposals has turned into a funded expedition, and the exact patch of seafloor where the cable finally went slack remains almost entirely unexplored. Somewhere down there, in water pressure that would crush a person instantly in darkness that no light has ever reached, a small metal capsule built to survive the deepest place on Earth is still keeping whatever happened to it a secret. If stories like this one keep you wondering what else is still sitting down there unexplained, following along for the next deep sea mystery is the easiest way to find out.